All right, this is the video lecture for AP Calc BC, and it's Chapter 5, Objective 2, and we're doing our log rules for integration. Okay, so that's going to be our focus. And before we get started, though, we want to do a little review of our polynomial division because we're going to be using this strategy to help us out. So like right here, I have what is called an improper fraction, right? The power in the numerator is larger than the power in the denominator, and so to simplify that, we would divide. And so I'm just going to go over like long division, but if you remember some synthetic, go ahead and do that as well. So we're going to do x minus 2 is dividing into 4x squared minus 2x plus 1. So that is our division and how we would set that up. So we look to see, okay, what do I multiply x by to get 4x squared? So I would multiply by 4x. So x times 4x is 4x squared. And then we would also distribute it to the negative 2. So 4x times negative 2 would be negative 8x. And then from here, we want to subtract, right? So we want to subtract. So I'm going to do subtract with a grouping, right? Because we want to subtract both of those terms. And so then we're going to distribute that negative in. So when I distribute the negative in, I will get a negative 4x squared here, and then that would become a positive, right? And that's like one of the common mistakes students make is they forget to distribute that negative in. So then our terms here will combine to 0, which they should. And then negative 2x plus 8x is positive 6x. And then we carry down the 1. And then we start all over again. So I look at it and I go, okay, what can I multiply the x by to get 6x? So what times x will give me 6x? And that would be a positive 6. And then now I distribute the 6 to the binomial here, my divisor. So 6 times x. And then 6 times negative 2. And we're going to subtract that quantity. And then I'm going to distribute the negative in. So distribute that into both terms. So that will become negative, that will become positive. And then this will combine to 0. And 1 plus 12 is 13. So that is my remainder. And so when I get that remainder of 13, I would want to add it, right? So I'm going to add it. And so I have a remainder of 13. And then I was dividing by x minus 2. And so that will be my long division. Okay? So a little review from your Math 3 days. And then just a couple of simplifying our logs just to make sure we're good on that. So remember, logs mean what is the power? Or what is the exponent, yeah? So what is the power for 2? So I will get 8. So what power is needed for 2 to turn into an 8? And that would be 3. And that would be because 2 cubed, right, is equal to 8. So because 2 cubed is equal to 8. So then on this one here, so we've done already a couple of these, but just to be sure, so I have this as a power, so I can move a power to the front, so that would be 4 times the natural log of e. And then remember, natural log is the same as log base e. So what power for e will give me e. So e to what power will give me e, and that would be 1. So this would be the same as 4 times 1, which would just be 4. Okay. All right, so that's just a little review off of that. And so now let's go ahead and talk about the reverse rules for derivatives. So just as a reminder, or inverse of finding the derivative of a natural log. Okay, so let's just review that real quick. So if I were to take the derivative of the natural log of u, I would get a fraction and then chain rule, right? So this would be u in the denominator and its derivative on top. So that would be the same as u to the negative 1 times u prime. So what we're looking at is, I know that if this is the derivative of that, then that means if I were to find the antiderivative of this, I would get that, right? Isn't that what that means? And so that's what we're working with. So we have the practice of finding the derivative to get that result. Now I'm going to look at it in this format though, and I'm going to say, okay, so what antiderivative, right? What's the antiderivative of this? So what did I take the derivative of to get this? And it's going to be a natural log. Okay, so let's take a look at that power, or that rule. So u is just some function of x, whatever that would be, like x squared, 3x minus 1, whatever. So if I have 1 over u du, that antiderivative is the natural log of u plus c. And we do absolute value because this does not have a domain restriction of like positive versus negative, but this does, right? So natural log can only be positive, but over here, this could be whatever, right? Could be positive, could be negative, doesn't have a restriction. So we have to put that absolute value in there. So alternate forms, so this is one way that you might see it. This is another way you might see it, right? Because 1 over u times du is that same, right? Well, that will still give you this here. Or I could bring the denominator up and make that a negative power, and then if I see that form, I know that. So all 3 of these forms are equivalent. The one that we will use is this one right here, probably 90% of the time. It doesn't mean these are not true, but we're always going to do a rewrite just like we did back in chapter 4. And so because we're always going to do that rewrite, it's going to always end up looking like that, okay? So then my question to you is, why not just do power rule? Because we know that if we have u to the n du, we would just add 1 to the power and then divide by the new power. So why not just apply that to this problem? Like, why natural log? Well, if I tried to add 1 to the power, negative 1 plus 1 is 0, and then divide by the new power, I would be dividing by 0. And so I can't, right? We can't divide by 0, so that's why we have that natural log. Okay, so enough yammering. Let's go ahead and take a look at a couple of examples. All right, so for this first one, just like we did in chapter 4, we always want to rewrite. Okay, some of you don't do that step, which is fine, but I will always do the rewrite. So we always want to rewrite it to where we have our grouped term and then our remaining terms and end with that dx. Like that's how I'm always going to get started. So I want to do my rewrite. So I see that 2 is just a coefficient, right? So I'm going to pull that 2 out to the front. And then I have to rewrite it, so I want my grouped with whatever the power is. Let me put it in on that. And so in this case, that 4x plus 3, I'm going to pull up to the top. And then there is my rewrite. So I have my 2 coefficient I pulled to the front. I have my group term and then my dx. And then just like we have in the past, we're going to let u equal what's in our grouped piece. So I'm going to let u equal 4x plus 3. And so this is just like our chapter 4. And then take the derivative of that. So that would be 4, and then we're going to multiply that dx over. And then we found our du, and then we need to adjust it as needed. So right here I have a dx in the problem, right? But I have a 4 dx here. So that adjustment is going to require me to divide by 4, right? So when I do that, I would have 1/4 of du is equal to dx. And then now I'm going to go ahead and do my substitution. So I'm going to use this information over here to substitute into here. So I will have a 2, and then 4x plus 3 gets replaced with u, and then dx gets replaced with 1/4 du. And then just like in chapter 4, we always are going to pull that 1/4 to the front, so feel free to do that in one step. So that would be just 2 over 4. And then we try one of the rules that we know. So we want to try power rule first. So if I add 1, that would make that 0, and then divide by 0, no can do. It is not a trig, right? Not a trig because there's no sine, cosine, tangent. So that means the only one I have left is the natural log, because the integral of u to the negative 1 du is that. So that is a new rule that we have. So 2/4 is the same as 1/2. So I cannot do power rule, so it's going to be a natural log. And so it's a natural log of the absolute value of u and then plus c. And then our very last step is we want to answer in terms of x, or we should be evaluating our limits. But there are no limits, so we're just going to go back into terms of x. So I'm going to take that 4x plus 3 right here and substitute it back into the equation. And there you have it. Ta-da. Okay, let's take a look at another problem here. All right, so I have a fraction, and so because I have a fraction, I want to rewrite it, yeah? So always grouped and then remaining terms. So I'm going to pull that x squared plus 4x minus 3 up to the top, and that will make it a -1 power. And then this is to a power of 1, right? So remember that if it's to a power of 1, yes, it's grouped, but it's not going to be our u, right? So what is to a non-power of 1, and that would be this one right here. So then this will end up being our u, okay? So we're going to let u equal x squared plus 4x minus 3. And then I'm going to take that derivative, so that will give me du is 2x plus 4, and then multiply that dx over. So then now once we do that, we're going to substitute. So u is x squared plus 4x minus 3, so all of that's going to swap out for u. And still to the -1 power. And then both 2x plus 4 and dx is the same as du, so both of those together are going to substitute for du. And then I run down my list. Can I do power rule? No, because if I add 1, I will get a 0 power, and I cannot divide by 0. Is it a trig rule? No. So then it must be natural log. So then this will be the same as the natural log of the absolute value of u, and then plus c. And then now back substitute. So I'm going to replace that u in terms of x. So I'm going to put it back in as x squared plus 4x. And how about a minus 3? That's like a plus. It's not. It's a minus. Okay. And then plus c. Okay. All right. So far, so good? Yeah? All right. Let's move on to the next one. Boop, over here. Okay. So this one right here. So again, I want to do a rewrite. Okay. So I'm going to pull both of these up to the top. And I'm going to have e and e cubed that I get to deal with. So that will give me x to the -1. And then natural log of x to the -1. So I have both of those to the -1, and I need to figure out, that's suspicious, because is this the grouped or is that the grouped? And it would be this one, right? Because if I were to say this is my group term, and I let u equal x, I'm really just saying, ooh, poo-poo to the variable, and I don't want to do that. So this is really my group term, so I'm going to scramble that around so it looks appropriate, right? All right, so that looks pretty good, right? So I'm going to let u equal my inside, and then I'm going to take that derivative. So the derivative of the natural log of x, so it follows the natural log goes in the denominator, and then its derivative in the numerator. So derivative of x is 1, and then multiply that dx over. So I'm just going to match these up better. So I know that I have 1 over x here and x to the -1, and those are just the same. And I do not need to write this step. I'm only doing it so you can maybe see that a little better. So 1 over x is the same as x to the -1. All right, so then let's go ahead and do our substitution. So I'm going to replace the natural log of x with u. So this will be u to the -1. And then both the x to the -1 and the dx are going to be with du. And then now don't forget this part right here. So these are in terms of x, right? Because of the with respect to x portion. So that means I need to be now in terms of u. So when x is equal to e cubed, right? So up here, x is equal to e cubed. I'm going to use this equation here. So then at x equals e cubed, I know I have u equals the natural log of x, which is just e cubed, right? And then that will just give me a value of 3. So then my upper limit should be a 3. And now I'm going to do the same thing for my bottom limit. So my bottom limit is that x is equal to e. And then I'm going to use this formula here. So u equals the natural log of x, which is just e. And then that is just equal to 1. Okay. All right. And then now go through your list. Can you do power rule? No. Is it a trig? No. So what does it have to be? Natural log. So then this will be the natural log of the absolute value of u. Switch notation from 1 to 3. And then substitute in the 3 first, and the absolute value of 3 is just 3, and then minus, substitute in the 1, natural log of 1. I don't know what this is, but I do know what this is. So I know that what power on e will give me 1, and that would be a power of 0, so that would be minus 0, which would just be the natural log of 3. Okay, so far so good. Looking good. All right, let's take a look at D. All right, so D and E. This is where long division comes in handy. Sorry, got distracted. This is where long division comes in handy. Why is that? Because I have an improper fraction. So my numerator here is a higher degree than my denominator. This one also. So that means I need to do long division. Long division. I have an improper fraction. The power or the degree in the numerator is higher than in the denominator. So here we go. Long division or synthetic, right? Whatever you prefer. Great time to hit pause, give it a whirl, and then check to see if you did it right, okay? So what am I going to multiply x by to get 2x squared? And that would be a 2x. And then now I'm going to distribute the 2x to both of those. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. And then I'm going to subtract that quantity. And then I am going to remember to distribute that negative in. So that negative will distribute in. And then now combine like terms. So that will give me 0. 7x plus 16x, or excuse me, 7 plus 6 is 13x. And then bring down the negative 3. And then start all over again. So now what am I going to multiply x by to get 13x? So I'm going to multiply x by 13, so positive 13. And then now distribute. So when I distribute, I'm going to multiply 13 times x. 13 times negative 3, and then I'm going to remember to subtract. So distribute in that negative, and so then I will get a 0 here and a 36 here. So then all of this is going to divide to that plus that remainder, right? So then I'm going to rewrite this. So I'm going to actually integrate 2x plus 13 plus, and then now my remainder, of 36 over x minus 3, and then with respect to x. So when I'm doing that long division, when I'm getting my 2x plus 13 and my remainder of 36, that's what that is equal to. And so that's why I'm doing a substitution. And so for this one, I'm going to go ahead and split up my integral because I am adding, so I'm allowed to do that. So I'm going to split it up, and I'm going to split it up by this portion here, separate from my remainder, okay? Whether you actually do that or you just do it like mental math, like that's fine as well. Okay, so all I'm doing is I'm going to integrate this portion separate from this portion. Okay, so over here, this is just a normal polynomial, so this would be just your normal like power rule stuff. So this would be add 1 to the power and divide. So that would give me 2, and then x squared divided by 2. And then the antiderivative of 13 would be 13x. And then there's going to be a plus c here, but I know I'm going to grab one out of here too, so I'll just use the plus c off of that. I'm going to do a rewrite here so that 36 can go to the front, and then the x minus 3 heads up. Okay. And then if you've been keeping up, great, then press pause and try to finish it out on your own, okay? All right, so I have a grouping to the negative 1. So then I'm going to go ahead and let u equal x minus 3 and then find that derivative, which would just be 1 dx. And then I'm going to reduce that. So I have x squared plus 13x plus 36. Replace my x minus 3 with u, and my dx will just be du. And then run through your list. Can we do power rule? No, because if I add 1, I get 0. Can I divide by 0? Yeah, no. It's not a trig, so it must be natural log. So then that would be natural log of the absolute value of u, and then plus c. And then my last step is always to go back into terms of x. And we call that a win. There you go. All right? Okay, so here we go. One more like that, long division. So this one I'm going to probably be a little tight for space. So I'm going to do a little like that. Okay, so let's do some long division here. So we have x plus 1, and we're going to divide that into 3x squared minus 4x plus 2. So give that a try, and then I will just work it out. Hopefully after the third one you're good. So I'm going to have 3x minus 7 plus my remainder over x plus 1. Okay, so, right, so 3x minus 7 plus my remainder 9 divided by x plus 1. And now split up the integrals so that your remainder you're working separately. And then I'm going to go ahead and pull that 9 out and move the x plus 1 up to the top. Okay. And then now I'm going to go ahead and integrate this. So I'm going to add 1 to the power. So that would be 3x squared minus 7x. And then we're going from 2 to 4. And then I forgot to divide by 2, so I'm going to do that. So that would be x squared over 2. And then we're going from 2 to 4. And then over here, so I'm going to do my u du. So I'm going to let u equal the inside, and then I'm going to take that derivative. So that would be 1 dx. So I'm going to run down here. So I have 3 halves x squared minus 7x from 2 to 4, and then plus 9. And then I'm going to replace x plus 1 with u, and then dx with du. And then I'm going to do my limit substitution, because up here these are in terms of x, but down here I'm going to be in terms of u. So when x is 2, 2 plus 1 is 3. When x is 4, 4 plus 1 is 5. Okay. And then now let's go ahead and do a little bit of evaluating over here. So I'm going to substitute in the 4, so that would be 16. 8, so that'd be 24. Hopefully I did that right. And then 7 times 4 is 28. And now minus, substitute in the 2, so that'd be 4, 2, 6. And then minus 14. Man, I hope I did that right. If not, oopsie. Okay. All right, and then let's go ahead and do the side here. So plus 9, so that 9 there. And then the antiderivative u to negative 1 will be natural log of u. And then we're going from 3 to 5. And then that would give me negative 4 minus negative 8, so negative 8. And then plus 9, and then substitute in 5, and then 3. And then feel free to do a little more arithmetic, or we can just call that a day. All right, so that is the end of that one. And then we have 2 more that we have to do, 2 more, okay? All right, so we already know those 2. And then we know 4 others, right? Secant, integral of secant tangent, integral of secant squared, so on and so forth. Well, here come these bad boys. So the integral of tangent, cotangent, secant, cosecant. They are all natural log problems, and that because if I were to rewrite this as sine over cosine and did my cosine to the -1 sine like rewrite, it turns into that u to the -1 substitution. So that's where this is coming from, and ditto on all the rest, okay? Because that's really 1 over cosine, cosine to the -1, 1 over sine, sine to the -1, right? So these all have that kind of -1 power. That is why they all turn into these natural logs. Okay? All right, so here's 4 more that we got to learn, right? Dang it. So we already had a few from before, and now we get a few more. So I think we're up to a total of like, I don't know, 132 to learn. Okay, maybe not. All right, so let's go ahead and take a look at this. So I have a grouping. So whenever I have a grouping, I've got to do my u to u. So I'm going to let u equal the grouping, which is 4x, and then I'm going to take that derivative, which is 4dx, and then divide by that 4. So then I have that 1/4 that I'm going to pull to the front, replace 4x with u, and then dx, of course, is du over 4, and I already pulled out the 1/4. And then I look at that list. That is a little frightening to memorize, and you can eeny, meeny, miny, mo. I'm going to go ahead and pick this one. So then that would be 1/4, and then negative, I'll pull that out front, natural log of the absolute value of the cosine of u plus c. And then go back and substitute, so that u is the same as 4x. And there you have it. All right, and then while I am thinking about it, why is there 2 here? Dang it. Okay, so, and I'm only answering that question because I know Arsh or Josh would ask me that. What? Okay, so this is why. So because if I were to pull this negative up to the front, which I can't, right, because it's a natural log. Okay, so that would be cosine of u to the -1. Well, cosine of u to the -1 is 1 over cosine. But what is 1 over cosine? It's secant, and that's why there's 2 here. Okay, so if you like the negative, leave it. If you're like, then rewrite it. Okay? All right, last problem, like legit last. Okay, so I have a grouping, so that means I need to do u to u. So u is going to be 1 minus x. Now I'm going to take that derivative, so that would be 0 minus 1, x is 0, so -1, and then dx. Divide by -1. And then I'm going to yank that 2 out to the front. So I will have secant, and then replace 1 minus x with u, and then dx is du over -1, but move that -1 over there. So then this would be just -2, and then the antiderivative of secant u du. One of the 34 that I need to know, I don't know, a lot, right? So I'm looking up here, integral of secant u is this guy right here. Something so lovely. So that would be natural log of the secant of u plus the tangent of u plus c. And very last step, don't leave it in terms of u, head back to x's. So that would be -2 natural log of secant of 1 minus x plus the tangent of 1 minus x and plus c. There you go.